Bataung here from iAfrican, again in the exhibition hall at Deep Learning Indaba. I'm saying again because we've actually been here for 3 days now conducting various interviews with speakers and guests, keynote addresses. And now we've got a special guest right here for you guys. Her name is Ilenna Jones, and she's one of the speakers at the Neuro-AI workshop happening right here at the Indaba. Ilenna, how are you?
I'm doing great. It's been really wonderful visiting Rwanda and trying the food, and I'm in the hotel nearby, and so it's been very. I've been able to stay close and be in the space of this village, the conference venue and everything. So it's been really nice being able to get back in touch with some friends and seeing familiar faces.
Beautiful, beautiful. Ilenna, let's start with the fundamentals and basics. What's the difference between traditional neuroscience and computational neuro-AI?
Yeah, so a lot of traditional neuroscience, neuroscience is very broad. Basically, one of the things that can define neuroscience is its subject matter, which is the nervous system, the brain. How does that work? And there are many different ways and methods that can be used to access the brain and try to generate knowledge about the brain. So a lot of that is through very experimental techniques. So anything between patch clamping, which is taking an electrode and measuring directly from a single neuron, to things like calcium imaging, where calcium is something that's produced in neurons, and you can take a video using a microscope to then image many, many neurons at once. You can also look at behavior. So if you have a mouse and it's behaving in an environment, you can then figure out what about its nervous system is causing its behavior. Computational neuroscience is more of a sub-selection of neuroscience that is defined by computational methods. And computational neuro-AI is using the computational methods that you might borrow from AI technology and AI development to better understand how the nervous system works. So this has just as broad as neuroscience is, this has very broad applications within neuroscience, often trying to take methods that are used to better understand how deep networks work and how you interpret how deep networks work, and then applying those to understand how biological neurons or biological networks work. You can also, with some of my research, I'm trying to simulate how biological neurons operate to be able to perform a task, like in AI models. AI models are usually set to a task, and then you test its performance. I want to take similar AI models, make them more biological, and then test their ability to perform tasks.
So some of my viewers are going to be like, wow, Ilenna, that's a lot of jargon.
Yeah.
That's a lot of computational. Break it down. Give us a case study, a practical use for computational AI. Give us a tool, something maybe they use in medicine or in the health space. I don't know. Just give us something practical that they can see, that we can touch.
Yes. So computational neuro-AI. So I would say that one of the most familiar use cases for AI for neuroscience is, I know. So there's a field in neuroscience called connectomics.
Okay.
And connectomics basically looks into the brain and sees how all of the different cells and neurons, all of that is connected. But when you do the process of doing this microscopy, so using the microscope to image parts of the brain so you can build a 3D construct, you need to be able to then track where does the cell begin and end. And that's very difficult to do by hand. AI methods, I think even developed by Google and a variety of other organizations, have developed image segmentation methods that is able to then take these microscope images and figure out where does one cell begin and where does one cell end. And that allows them to do a high throughput, I say high throughput, that might be another jargon, but with high efficiency, they're able to then label all of these neurons so that people can then do analyses on how the neurons in a biological network are connected.
So, Alana, one of the things we spoke about is the fact that you went to the Mbizo in Cape Town, right?
Yes.
And you attended summer school there. There were other sort of brains and people in that space. Now, I want to ask you a very critical question. Some of these areas of speciality are highly specialized and highly niche. Are you happy with the levels of diversity, inclusivity, in terms of people of color, in terms of Africans, in terms of females within the neuro-AI space?
Yeah. So that's a really good question. So I think that when it comes to where I tend to be, so like I'm at Harvard. I did my PhD in a primarily white institution, historically white institution at University of Pennsylvania. And that's where I got started with neuro-AI. I'm often the only Black woman in those spaces. And when I go to computational neuroscience conferences, I might see very few, or maybe even count on one hand how many Black women's faces I might see at the conferences. But I think that even though we are trailblazers, us women, in this very new space, I think that there's a lot to be said about the educational resources that can allow other Black women, African women, to find opportunities to access this space. So there is the Mbizo, like we talked about,
100%.
which is the Simons Computational Neuroscience Mbizo, which takes place in Cape Town, South Africa, every January. That's been a wonderful place where I've met. I'm involved in the admissions each year. And we actually do our best to try to have even numbers of men and women in the school and a majority of Africans in this school. So you're going to see many African women in this school, and they all have access to a variety of opportunities through the professors there as well as through their fellow classmates. But there's also, that's a 30-person school each year. There are other resources that are available that are at scale, where more people can find access to computational neuroscience and neuro-AI. I'll shout out the Neuromatch Academy, which offers a school or a course in computational neuroscience, deep learning, and neuro-AI. And all three of them are available during the summer to do synchronously. It's over Zoom. It's all over the world. They've had thousands of students at this point. It started in 2020 during the pandemic to deal with the need of more in-depth education about computational neuroscience at scale that is not so limited to different privileged areas, say in Massachusetts or in the UK or Portugal. They're very privileged places that may not have the ability to scale up to allow students to access these opportunities. So Neuromatch Academy, I think, has been excellent. There's Trend Kamina, which is one of my students called it pre-Mbizo because it's very it helps you really get a good start in computational neuroscience and thinking about neuro-AI. There's also, if you're already in the machine learning space and you're wanting to get more into neuro-AI, there's also Neuro-4ML, that's Neuro-4ML. And that's also available as an open source resource for students who are already trained in more quantitative backgrounds, but want to get more into neuroscience. So there's tons of opportunities. And I'm sure that because there's a combination of schools like Mbizo and summer schools or resources like Neuromatch, Neuro-4ML, and Trend Kamina, that more students like me, and African women can make their way into these spaces. I don't think that it's going to be this way for long.
Thank you for sharing. I think it's important that you share those insights on the different programs, institute, platforms. So a lot of our viewers that are interested in this space can go immediately tap into that. But now we've solved, or rather you've tackled one area, right? Which is, the skills and the capacity side. There's the issue of funding. There's the issue of access to computational resources. There's issues of access to open models, to play around with some of these tools. How, coming from the privileged, I'd sort of say in inverted commas, institutions that you come from, how would you how would you advise universities that might not have the levels of access, that much more, prestigious universities have to overcome some of these challenges in order to get the same level of tech stack tools and. So the output is just as, on par or even better than prestigious institutions.
Yeah. I'm going to have to punt this one because I'm not actually sure.
Okay.
But I think I think that one thing that comes to mind is that some universities, well, these big companies.
Yes.
They have huge amounts of compute. One thing that they might be able to do, that I know that Harvard Kempner Institute, where I'm coming from, is doing is, if they don't necessarily have the mechanisms to give out money, maybe they can provide the mechanisms to give out compute. So I know that the Kempner Institute at Harvard is starting up a grant program where they have a huge compute cluster. They've gotten so much funding to get all of these resources that what they're going to do is have this grant program for different teams at different universities to apply to have access to that compute for some time. So if you have a project and you really want to lift it up off the ground or to really speed up the testing or hyperparameter tuning and things like that, then I imagine that you could use this kind of model, or say Google could have this kind of model, if they don't already, I'm not sure, to allow more people, more teams and students and labs from less resourced backgrounds to be able to have access to compute. And this can be done in a way that is not an exchange of monies for compute. It can be based off of merit and application and just having an overall desire to have a more equitable presence in this space.
Dr. Ilenna, your audience right now for your workshop is an African audience. Researchers, engineers on the continent. Top 3 insights that they should get away from your workshop. Walk us through them.
Yes. Okay. So top 3
Insights.
So one insight is that neuroscience is an interesting place to gain insights into producing biologically inspired artificial neural networks and AI. At the very least, in the history of computational neuroscience, in the history of AI, neuroscience and computer science even have had this interesting on-off collaboration of developing certain ideas that have propelled each of those fields forward. And I believe that not so many people know about this history, and my hope is that the audience at this workshop will be able to appreciate that and maybe try to be one of the leaders that can see how each field can propel itself even further. The second insight that I think workshop attendees can get is kind of what I was saying before, which is that there are actually many opportunities to access the computational neuroscience space. I think that a mechanism of accessing this space is having the initiative to try to wrestle with these concepts on your own or with friends and try to be industrious and take initiative, start projects, and try to reach out to faculty, professors, or if there's researchers at Google or Meta that are also doing neuroscience-like research or Neuro-AI type research, perhaps they're out there and they can be accessed. I think key to that is, that I may not have said, is that there are those resources that I mentioned and the schools that I mentioned that allow people to then connect to those who may already have access to those opportunities so that we can pass them along and pay it forward. And I guess the third insight that I want to get at is connected to that last point, which is that everyone at the Neuro-AI workshop wants to pay it forward.
100%.
I think that when it comes to everyone there, we have access to a lot of resources and opportunities, and that's how we've been able to get to where we've gone. And we appreciate that. People along the way have allowed us to get to this point, and we want to be there for those who are interested and want to push themselves to go further, so that we can provide them the opportunities that were given to us and to show them that it's possible, like for us. So, I think those were my 3 insights.
Dr. Ilenna, I like what you said about paying it forward. I think it's very critical, and I like the fact that you use that word, because I'd like to say to you, you stand at a very interesting place in history. You're very fortunate and very privileged to have had access to the information and the knowledge that you have currently. And I encourage you to keep opening those doors for our brothers and sisters. We need 1 million Dr. Jones. We need 1 million of you in this space, because there's a lot of work to do. And you can't do it alone. And we need more of our brothers and sisters in these spaces. And I think the work that you're doing is good. You encouraged me a lot when you said at Imbizo in Cape Town, you're part of the selection process. And you intentionally try and, balance those numbers. And I commend you for that. We need our own to have that sort of foresight and be intentional about promoting our brothers and sisters into that space, and understanding that we're not slow. You just got to give people some time to get to cross the bridge. You know what I mean?
Oh, yeah. I would like to even jump in and say that I've met so many of my past students and students that were at the Imbizo even before I was introduced to the program, and I see that they are thriving. One of my students told me, oh man, I was exposed to so many things at the Imbizo, and only now, 2-3 years later, I'm starting to finally understand the things that I was exposed to, and I want more, and I'm really trying to apply for programs. And I've seen him, he's been asking so many different people, like, oh, what kinds of opportunities are here or there, and it's voracious. It's voracious. And I think that one of the things that inspires me about the Imbizo is that everyone wants to be there and everyone wants to take advantage of that opportunity. And it's very inspiring, because I know that different people, some people kind of waltz on in, some people think they're entitled, but I think all of the Imbizo students understand how precious of an opportunity it is. And they also want to pay it forward as a result. I mean, I joined the Imbizo as a TA kind of like during the end of my PhD. I didn't really know what all was going on, but when I was given the opportunity to do this, I said, yes, I have to do this. I feel like when I'm in some parts of the computational space, but also deep in my PhD, I kind of really crave the ability to impact other people. And one of the reasons why I got into neuroscience was to help people. I wanted to help with psychiatric illness. And I found that I've been able to, in my roundabout process of figuring out how to do that, but also do computational work and also be in the AI space, I feel like in the intermediate and I guess for the long term, I want to teach people. I want to empower people. And the Mbizo really showed me that the work that I put in comes out 10, 20, 100-fold through every student and what they feel like and what they realize they can accomplish.
Reminder to our viewers, we're out in the exhibition hall at the Deep Learning Indaba. So if you're hearing voices, it's busy, it's buzzing. There's companies, like it's busy. So don't get it twisted. We out here. We're really on the ground. We're out here trying to make AI and machine learning fun for you guys at home there. So you get the insights, but you also get the knowledge and exposure to the opportunities that are out here. And you keep subscribing, you keep watching, you keep giving it to you. We out.